Hello, everyone. Welcome. It's nice to see you here, coming to listen me talking about regular expressions. And before we start, just a quick introduction of myself. My name is Rustam. I live and work in Norway. I'm a lead Norwegian Java user group called JavaBin. Um, I'm I work as a consultant, do a lot of development and things, and through that kind of work, I find some topics that are kind of, people think that they can, but they sometimes it's a little bit hard to do that. And regular expressions, I realize that's one of them, and it's like people would think that, oh well, you're talking about that thing. We know that. I know how to do that. I'll fix that. I'll in a second, and I'll do everything. And then I ask them usually, do you pass something I call a napkin test? If I give you a napkin, I think I'm back. If I give you a napkin in a pub and I ask you to write a regular expression to fix something, will you be able to do that? And then they start kind of, scratching their head and like, I don't know, I'm not sure about that. So, how many of you have seen this one? Yeah, well, a couple of hands, that's good. That's the vision. We're gonna be there. I mean, that's my point. So when you get out of this door, walking out, you will be there, hopefully. So you'll know how to use that. You'll remember all those things that you've learned before. You actually probably will be able to pass that napkin test. But it's not all fantastic blue skies and no clouds or anything. So you had 99 problems, then tried to solve it with the regular expressions, and well, then you have 100 at least. And just to show you the reality, it's the real code that I found. A colleague of mine actually found in somewhere deep inside. I just copied it, so it's basically just ignore the language, ignore everything. Just look at the way the person who wrote that thought. It's kind of amazing. All I did was just to show line by line things that happened there, like the timeline of the whole thing. So you have a method, validate email, that validates email, right? So you start optimistically. You're like, oh, fantastic! I'm gonna write. I know regex. I can do that. And then you start writing that, and then you write and write and write, and then you come up with this fantastic thing. It works for most of the cases, and then you realize that it doesn't work for some others. And then you're like, well, that's not going to work. Okay, I'll do this. Yeah, right. So I heard somebody saying, oh shit. Yep. That's exactly what you do, right? And then you're like, oh yeah, this is definitely going to work. Perfect. And then you run, and then it works for your weird corner cases, and then it doesn't work for some again. So you do this. Can you guess what the third and last line is? Well, yeah, madness. That's perfectly true. So it's like this is the motivation for the talk, because like the regular expressions, they're quite okay, easy to do. Most of the people like, yeah, I know that. I can do that. And then you end up doing things like that. So that's what we're trying to fix now. So we're going to go through the basics now, go through things, explain, and we'll look at this weird kind of things that will probably, hopefully, stop you doing that. This is real code. This is running somewhere, at least used to, until I think we fixed that. Yep. So before we start, there are two tools that I used. One of them is regexpal, and the other one is regexper.com. One of them is I'm using to generate all those kind of really nice train-like diagrams to explain the regular expressions. You'll see them a lot through the presentation. It's really good, and I really encourage you to try to use that. It's much easier to look at than this. I really hope. So let's start with just a simple example. Just ignore the Ignore what it does. Ignore the everything. Just I wanted to show you some tiny little regular expression. Well, maybe not that little. It's something to do to parse some logs and stuff like that. So it's like it's not really important what it does. We'll look at that in a bit. Basically, this is just an example, and I wanted to introduce regular expressions. So, how many of you have used regular expressions? Oh yeah, fantastic. Almost all hands up in the air. Fantastic, yeah. So I don't really need to introduce it that much. Basically, it's a very powerful tool. It's implemented in most of the languages. You would have it in Java, Perl, whatever, you know. And by the way, that email example, packages like Perl, they have even their own packages for validating email. So don't try to write that thing on your own. You got that covered. Just saying. There is tons of materials. I could have been talking about that probably for the whole track. I don't want to do that. We'll need many hours. You'll need a lot of coffee, and well, no, we're not going to do that. We're going to cover kind of basics and see what we can learn from that. There are many flavors of this thing. I mean, there's a lot of implementations that are a little bit different. We're going to do the vanilla thing that works on most of the languages and implementations of that. What you're going to use normally regular expressions, usually two things, right? It's find a text to do something, to verify or match something. If there is something in a text, you have huge file, log file, whatever, you want to find tiny little thing, you can use regular expressions for that, defining the pattern and everything. The other use would be using it for replacing something. So you replace one thing with another. Also a typical example, right? So that's the normal use. And what we have here is a set of meta characters that have those weird brackets around them, like squarey and curly and all the other ones. Without them, it's basically text search. Without that, you can just write ABCD and it will look for ABCD and everything would be happy and everything. But then you can do much more with those meta characters. And we'll be looking at that. As an example, I took also a live log file from a live system. I just anonymized it quite a bit, so it's not really recognizable what it is and where it comes from. But basically, it could be anything. I took a log file from log4j. That's kind of thing that everybody, most of us at least, would be able to relate to and have seen before. So you see there are some funny words there. It's Norwegian, just so you're not getting scared or anything. So let's start simple. We want to match just either info or warn. So how it's going to work, it's going to be, you're saying basically here, any character, which is like dot star. And then the regular expression, the way it works, it eats letter by letter. So it would go like, do you have I? Yes. Okay, fine. Do you have N? Yes, perfect. F. Oh, good. If it wouldn't get that match, so it would go like, do I have W, A, R, N, and so on. So it would just take letter by letter and try. And this is a very simple thing, and we already here introducing some things. We're saying, we have this dot thing, saying any character, so whatever. Star thing that says as many as you like. It might be 0, it might be many. I don't care. I'm also only interested in 4 letters, INFO or WARN, and that's all I need. And then I don't care what's the rest. I just need that to match that. That's really simple, right? So if you use that on our example, you'll get those lines. The yellow and blue, they are just alternating colors just to make sure that, well, you see that's different matches. So it's 4 matches there, right? Fine, that's easy. So now we get a little bit more bold in a way. We want to match a year, a date, a month, a date, and then error. So what we're saying here, now we're introducing some more stuff here. We're introducing all those character classes with the square brackets. So you say that I want to have 0 to 9, that's my character class. I want to have match anything that's between 0 and 9. That's a really interesting thing to say. If you want to say letters, you would say A to Z, for example, or you can say A, B, C, D, E, F. and it will be only them, those letters, or A to F or whatever, the curly brackets thing, it's a quantifier. So you're saying I want to have anything that belongs to the class of numbers, which is between 0 and 9. I want it 4 times. Then I want a dash, which is just a string. And then I want 2 more numbers and dash and 2 more numbers. Then I want anything. And then I want to have a word error there. And I want to have anything after that again. Again, nice, easy, right? All right. The other thing is that the normal, the usual brackets or parentheses, they are the groups. So you're actually defining 1, 2, 3, 4 groups. No, actually 5 groups here. All those nested parentheses, brackets, whatever, they are a group. So you can actually refer to that group 1, 2, 3, 4, and so on. It's another thing. It's funny. It starts counting from 1, not from 0, as what we programmers are used to. Basically, 0 is the whole thing. So just so you know that. So you remember that, recall that. So if you're going to match that, that will be this one, right? Perfect. I have my date. I have that whatever part, the dots star. And then I have error, and we're happy, right? Perfect. Okay. I want to match IP addresses now. The one we saw in this line, right? I want to match that. I want to see if it matches my server, whatever. So what I'm doing here, I'm introducing some more stuff to the regular expressions. And here starts the fun part. You have same characters doing 2 different kind of work, depending on where they are in the line, and if they're in the character class things, or if they're just on their own, and so on. So we start with this little weird sign. I call it a hat. Power off, whatever. That in this case, when it's there, it means start of the line. We know that, right? But then you have another one here, but it's in the square brackets. That means totally different thing. And then you have to be careful with that, because if you don't think, even if you know about that, you kind of might just forget about that, and then you're like, oh, that doesn't work. Now it means totally different thing. It's a negation. So I want to say that I'll have at my start of my line, I'm going to have anything, as many things of it as I want. I want numbers 1, 9, 2. Then I'm backslashing a dot. You know why, right? Because the dot in reg.ex means anything. So actually, I could write it like this, but that wouldn't work, right? Because that's the first thing you do. You're like, oh well, IPR is perfect. That thing doesn't work because the dot means anything. So you'll actually get a match for IP addresses, or you would get a match for 192A168B0, whatever, and you don't want that. So I'm backslashing all the dots, saying that it's actually a dot. It's a text character dot. Then I'm going to 6, and then I'm opening the character class thing and saying not 9. So I want to have anything but 9 after 6. And then I'm saying like, well, okay, anything from that, from there on. Anything, and the dollar thing at the end is the end of line. So now I'm looking at one line. And but there is a problem with that, because do you see the problem? Well, the problem is that if I have there is a pretty good chance that anything after 6 will not be matched. It will be part of that group of dot star, because, well, there might be even 9 there, and it will be just, it will, well, it's not 9, but anything else might end up in that group, because especially if you have like 3 digit at the end after the last dot, then you will not get that. And that's another thing. That's all those kind of things. I'm trying to show you all those things that seem really simple, but then you're like, wait a second, that works for my case, but it also works for those weird cases everywhere else, like with that email example, right? So this is the other one. This is the bad way of writing that with the dots. Matching your IP address works perfectly fine. It matches a bunch of other things that you don't want to be matched. And well, there you go. See, when I draw the diagram of that thing, it would say 192 any character, 168 any character, and so on, so on, so on. A little bit different than this, right? Now it's actually being read as a string. So we want to fix that problem that the last digit won't be as a part of that match. It would end up in that group of dot star. And you don't want to do that. Maybe you want to use that IP address to copy it from somewhere with back references and everything that we'll cover in a little bit. So we want to fix that. Okay, how can we fix that? Well, this is the match, right? We can fix it like this. We can say, okay, we'll have 6 there. Well, all the way until 6 is the same kind of regular expression. After that, we can say, like, okay, it's going to be 0, 9, 0 to 9, and there's a plus. And then I thought it would fix the problem, but then the last time I was looking through those slides, and I was like, wait a second. It won't. There is a bug there. Because the thing is that I'll still be able to match IP addresses ending with 69 something, or just 69 or whatever, because I'm saying here that I want to have as many, at least one, but could be many numbers, and then not 9. So it could be like a million numbers, and then it would be 9, or maybe not 9 or anything that would match that. Bug again, right? It looks okay, and then oh, that doesn't work. So this is the explanation, right? 6, 1 off, 0 to 9, as many times as you want, just going round and round and round and round. And maybe at the end, well, I don't want a 9 there, but I can have like a first 100 characters of pi there, and you'll still match that. Do you want that? Nah, probably not. And then there are groups. It's actually showing you the groups. So group number 1 is this one, because that's the only thing in parentheses. So if I would add parentheses over there, that would be group 1, this would be group 2, and so on. Another thing that is really kind of good to have in your toolbox is that question mark. It's also a weird one. It's like the same way that hat thing has different meanings. That one is also having quite a few meanings in regular expressions, so it's good to think about that. In this case, it's the optional thing. So if you're like preferring English or American way of spelling things, you can do like this, flavor. So maybe there'll be you there, maybe not. I don't know, I don't care. I want to match both. So it's like in the train language, it would be like a station of flavor and R, and it might pass the station of U, might not. You know, it's optional. I don't care. I want them both, and that's fine. So quantifiers, the one we saw till now, before we go on. 0 or many, right? 1 or many. 0 many, 1 many. Maybe. A number that's a maximum number. So you could say at least 3 times, or definitely 3 times. And this one is different. This one is actually minimum and maximum, saying I want to have that thing between 2 or 3 times. I want that number to be, because sometimes my years are 2 digits, sometimes my year is 4 digits. So I want to have 2 digits or 4 digits, between 2 and 4. But then you will have a problem that you will match 3 digits as well, right? So you have to think about that. So things get quite fast, quite complicated when you do that kind of things. So grouping. That's been what we've been looking at already. This is here you have 2 different groups. First one, well, actually, the first one is not a group. First one is or. That's another thing. Irregular expressions, they're using parentheses for 2 different things. You're either saying either that, or the second set of parameters, that's actually a group. What you can also do, which is a good thing to know, that people tend to forget, is that you can have nameless groups. Because when you saw that on the diagram, it would say group 1. You can even give names to those groups and everything. But if you add a question mark, that's another use of question mark. So now it's not optional or anything. It's now you're just saying that my group should not have a name. You don't really have to. You're telling to the regular expression compiler saying that, hey, I'm using this group here because I want to do stuff with that, but don't really remember it. I'm going to use it for something else. I'm writing it down for make it more readable, or I can do something some other things, but don't remember it. I don't want you to keep a track of it, and it's a performance thing. So if you don't need to use that, you just do that. It will leave it. It won't be in that list of groups it matches and actually remembers, because like if you're going through a huge file and you have like lots of matches, it will be a lot of memory and a lot of power you're going to keeping track of unused groups. So another good thing to think about, right? Let's talk about something else. I briefly said in the beginning that the way regular expressions works is just looks at the character by character and just moves on. So it's basically like, the PacMan eating through the dots until it meets the ghost. No, no ghosts here most of the time. But basically, it just actually there is. I'll get back to that. There is a scary thing that you can actually make the compilers crash with a really simple thing. So the way it works, I say that I have this group. I want to have WA, and it will go like, oh, I found W. Fine. And then we'll go move one character more, and it's like, oh, I found A. Perfect. And now it's the reading point. It's right there where the A ends. So it's just before reading R and going into eating the rest of your text. And now we get to something more. Really nice thing and really scary thing. It's the look-aheads. They're really useful. They're really useful to do. In many cases, but there also could be a little bit scary, and that's depending on the engine you're using. That's actually might be the thing that actually is able to crash your engine. You might just because of all those things, he has to keep all track on all pointers and all those things with look aheads and look behinds and all those kind of things. And what we have here is an example of positive look ahead. So basically, you're saying, I want you to match WA and stop at after A, sorry, as long as the next letters or those 4 letters are actually worn. So if there is something in the log talking about war files or something like that, it won't match that. So you're looking ahead of you without actually moving the cursor, because you might want to do something. So you might want to replace that little WA with something else, right? Or whatever. So this is the example, right? With the positive look ahead, it will actually match warnings, but not. I think I have war file somewhere here, just for fun. Yeah, here, war file warn. I did that on purpose, just to show you that it's actually not matching that because of the positive look ahead. But it will match warn and warning because the 4 letters there are warn. Good thing, right? So look arounds. There is a look ahead. We saw that now, right? There is a look behind. Basically, it's a kind of same idea, but you get matches to WA, but you want to actually go back and see if there is a special string there behind that, because you want to have, I don't know, special signature for your error, so special date, special whatever. But so you will actually get a match for that, and then you want to, okay, wait, go back, check if it's the right date, and then I can replace WA with something else instead of matching the whole date and WA and everything, and then parsing and doing all those things. You can do a lot of things with look aheads and look arounds. That being said, you might want to also minimize use of that because it's a little bit tricky and it's kind of hard to debug and to see what's going on. You have to try draw all those train diagrams to see what's going on and so on. There is, of course, both of those two. They are positive look-aheads. So if there is, do something, right? So there are like the brothers, siblings of those two. There are negative ones. So basically, do something if that string is not that I'm writing there, the foo string, but do something else. So, quick example of look-aheads. I did this thing with Notepad++, just to have real simple visual kind of thing. You have a list of people with company addresses, and you want to match all those emails, but you want to match it only if it's an email. So you want to see like, okay, if that thing starts with the less sign, and there is something, whatever, I don't care, and there is a greater than sign, then I'm good. I want to match that. If not, then it's okay. It will work for all of the cases here without look ahead as well, but you sometimes it won't, because if you don't have the greater sign, it will actually, there are things you might want to use the look ahead here. And if you do what I did here, I just clicked on replace, with just replacing with nothing. So it basically would delete all of them. It's fine. That works, right? And then I want to do the opposite. I have back reference, which is another thing that we have from grouping, is that you have this funny looking regex basically saying the name and last name with the space in between. So anything, space, anything. And then you're doing funny stuff. You can actually build up the emails from that again. You're actually saying the first group, space, second group, less than sign, first group, dot, second group, company, and then the greater sign, greater than sign. It will work for most of the cases, but there is one guy there without, so actually you will get like this. Another thing to think about that's one of these things that you should actually know your data quite well. You should be really careful what you want to match and actually what you don't want to match. This is really good thing to keep in mind. It's very, very quick to do. It's very like things that you do that you take things for granted. It's like, oh well, it matches my things for perfect, and then you're going through like, I don't know, a gig of data, and then you get lots of more matches than it's actually you should. I want to talk about something else now. Again, you remember that PacMan thing? I want to talk about greed, because that PacMan, he's eating all those dots and kind of can't stop. It just eats and eats and eats. So that's pretty much the same way regular expressions work. It just eats the text as much as it can until it's been told to stop. So that's the thing. By default, the regular expressions are greedy. So if I have a random string there saying like, well, something is awesome, in HTML it will be something like that something is em, emphasize awesome, em, close tag. So I want to write a quick regex that matches that and replaces awesome with something else, or replaces em tags with something else or something like that. Well, actually, in this case, I would maybe want to replace that with strong or something, right? That. And then I was like, okay, I have this less sign. I want to have at least one character there because all the tags at least have something in there. And I have the other one, the closing tag. So, result, you remember the greed part, right? Well, it will eat all the way until it can't find any more of those closing ones, and it will just be there, and it's like your dog with a stick and waving with a tail. It's really happy. It's like, look, I found it. It's like, well, that's not what I wanted you to find, right? Okay, you take a second run at that. you can actually turn that greed off. You can say that, look, stop the first time you match anything. Don't go any further. Just stop. The first time you see that greater than sign, you're good. Just stop there. And then, yeah, it works, right? So this is the greed. Greed is another thing that you really want to think about when you're matching things. And it's very important. It's very easy to confuse things and get things out of hands a little bit. That being said, I must warn you about parsing HTML with regular expressions, because how many of you have seen this one? It's been on Stack Overflow for quite a long while. No one? Really? Oh, nice. You're in for a surprise. This is really good. It's still out there. Last time I checked, it's a question on Stack Overflow saying like, "Hey, I want to match that thing with HTML and stuff, and I want to use regular expressions to do that. Can I do that? Can you help me with that? Because I'm having a little bit of trouble." And there were like many. Well, first there are many upvotes. Personally, I think they're missing like 10 more upvotes, but that's another thing. But it's a lot of upvotes for that, and then there is lots of questions. Answers. Sorry. And then there is this fantastic answer at the end before moderators close down that thread. It's this one. And it's I'm not sure you'll be able to read the whole thing, but you should, so you can read that at home or whatever. I'll give you the link. The basically idea is that he kind of starts pretty normal, and then towards the end he would get crazy, like start writing things weirdly, the characters would get weird, all those things would be crazy. And he's like, have you tried using XML parser instead? And then this note is really good. This is from moderators before they closed the thread. They were like, stop reporting issues to us. This is actually how it's supposed to look. We don't have any encoding problems. That's actually the intended way to show that. And yeah, well, the pony, he comes. That's how he ends, you know. And that's pretty much the word of advice for you. So don't try to parse HTML with regular expressions, because you will get crazy. There is the link. It's also good for your neck to do like movements like back and forth, right? So that's for ergonomic reasons I placed it over there, mostly because I didn't have space, but that's another thing. So Quantifiers revisited. You want more of that link? Take pictures? No? Everybody's happy? Fine. Okay, quantify. So what do we have? We have greed. All of them are greedy. So all the quantifiers like 0 or many, 1 or many, maybe, min, max, they're all greedy. The non-greedy brothers or sisters of those are these ones. So you just do exactly the same thing, you just add another question mark. And that's another funny part of using question mark for so many different things, right? You have 2 question marks in 2 different roles. So one of them is turning off the greed, the other one is saying maybe. Really good thing to be aware of. So the final recap, what you should keep in mind. You should know your data. This is the first thing that you should do. You should really know what you're actually having, what you're sitting on. You should know what you should match, definitely. But at least important thing, maybe even more important than that, is that you should know what not to match. Because otherwise you will get all those funny things, right? With the IP addresses and everything. You should know your flavor. As I told you in this beginning, there are different flavors of that thing. There are like different implementations. There is Perl, there is Java, there is .NET, there is, I don't know, millions of them. All of them are a little bit different. Some have like funny characters. You can say like \S and \W for spaces and words and things. And flavor, like the vanilla flavor doesn't have that, and so on. You know. You should know your engine. That's the part where the breaking of the engine or of the compiler or whatever it's running regular expressions comes. There are 2 different engines, 2 different kind of schools of engines in a way. It's DFA and NFA. NFA is reg.ex directed, so it actually looks at the reg.ex and then it tries to match it to the text. The other one is different. The DFA would be the opposite. It's text directed, so it actually looks at the text and then tries to match your regular expression. And they implement things differently with all those pointers pointing at different things, because you would have like groups and everything and all those things all together. You'll have lots of pointers. And there is a funny thing. You can write, I think, one-liner of text and tiny little regular expression. That's the easiest way to check if you have NFA or DFA engine. If you have one of those, your program will be just hanging. The other one would just give you an answer in split of a second, just like this. The second one would be just hanging and using all the CPU and will never finish. That's the difference, basically. So you have to know the DFA and FA thing. That's because it does a lot of backtracking, because it goes somewhere and then it would go back to see if it actually matches things and go back and forth. And that's another reason to be careful with look aheads and look behinds and all those things. Greediness you should think about. You should think about non-capturing parentheses, those question mark, colon, blah, blah, those groups that have no names, that are not non-capturing, they're called, because of the performance issues, right? Anchors. The anchors are those that we saw at the end or the beginning of the line, saying that this is the beginning, this is the end of the line, the dollar character and the hat thing. And well, that would be it, but we have some time and I want to show you some more funny examples. I want to just continue on IP thing. I know it's artificially made example. Yes, it is, but I think it's still good one that shows how weird things can get, but still how powerful that thing is, and how you can express a lot of things and put a lot of logic in regular expressions. I might not encourage you to do that because it's kind of hard to read afterwards, like a year after, or maybe if somebody else is reading your code, it's even worse, right? So we want to match an IP, any kind of IP. And then you're like, oh, well, perfect, I can do that. Right? I want to have start of the line, 0 to 9, at least one character, a string dot, not any kind of dot, any kind of character, but a dot. And then I want to do it like 4 times, and there's the end of the line, and I'm happy with that, right? Perfect. Not really, right? All of those are matched, all those in yellow or blue, except the last line, which is string, obviously, doesn't match, right? So that didn't work. Okay, fine, I'll refine that, or I'll do that better. I can do it like this. I can say, start of the line, digit, 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 dot, digit, 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 dot, and or you can do it, of course, I mean, I just wrote it like this, so it will be easier to read, but you can do like digit, 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 dot, and then repeat it 3 times, or you can repeat it 3 times with dots, or you can do things like that, right? You can use the quantifiers. But don't think about that for now. So, yeah, it kind of works. Not really, right? The real IP address there on line 4 is not matched, but the other ones that are weird ones, they're there. So that didn't work. Okay. Third one. Okay, I can do it better. I can say it's digit, but it's between 1 and 3 characters. It might be 1, might be 3, and then it should be dot, and then it will be digit, 1, 2, 3 digits, maybe. I don't know how many, but you decide, You give that to the compiler, and compiler is like, yay, fantastic, I found it. And then it finds, actually we're getting there, right? The only one is there that's not supposed to be there is, well, actually 2 of them that are not supposed to be there, right? 2 and 3. But we're getting there. Now we're actually matching 2 and 3 and 1 characters and, all that kind of things. So that doesn't work. Okay, fine. What we can do now? And that's the cool one. I like that one. I actually did it like character for character. You say it starts with the line. Then you say all that. That's the first number between dots. Oh, beginning of the line and the dot, the first one. You see what's going on here? You're actually putting in quite a lot of logic here, because we all know that the IP addresses, they have to have some kind of pattern. They can't be more than 255. They have to be between 1 and 255, and it could be 0 for some, but not in the beginning. All those kind of things, right? Well, actually, here it says that it could. But that's what you do. You add a lot of logic in here. So you're actually saying first character will be either 0 or 1, maybe. Then I will have a digit and maybe another digit. Or actually, this is, no, digit, and making it not greedy. So it won't eat all the way through all the numbers. And then I say or, because that's the case where my numbers start with 0 and 1. Or I want to have it start with 2, but then the next characters should be between 0 and 4, because it's like I want to have it all the way until 4. So 200 something. Then another digit, so 2, 4 something, whatever, doesn't matter. 249, 240, everything works. Or I have this corner case of 250 to 255. So now you actually have quite a lot of logic in here, right? It seems really logical, but to come up with this thing, it takes some time. You know, you have to think, you have to really think what you're actually trying to match and how things are really looking like in your text. And well, you just repeat that 4 times, or again, you can use quantifiers, of course, but well, for this case, we just do like this. And guess what? Hey, it works. Quite a lot of logic, quite a lot of things, and it's like almost like parsing an email, putting a lot of logic and saying like how it's supposed to be and how your domain names can be. How can it be 1 letter? Can it be 2 letters at the end? And all those kind of things, right? But this is just a simple example to demonstrate how much logic you can actually put into regular expression. For me, it was like when first time I saw that, I was like, this is actually pretty good. This is this is a very good way of thinking. It made me think about some other regular expressions, and when I was writing those for some different reasons, for different projects and everything. So that's your new reality now, hopefully. So now you can actually save the world. You can run into the room screaming, "Stand back! I know regular expressions." Tap something and run away. Probably because it's not working, but no, it's not. It's of course it's gonna work. Now you're experts, right? So yeah, that's pretty much it. Thank you. There is my contact information. Write me an email, whatever. Tweet. Question answers? Anyone? Yes, there is a hand over there. I see. Wait for the mic, so everyone can hear you.
Hi.
Hi.
Maybe you know some training tools, best training tools for regular expressions to start with, to be the best in this.
Training
Thank
tools,
you.
yes. Good question. That's the point. One of the points that I was. That's why I was showing you those 2 tools. They're really simple. They're not really anything fancy, but they will actually explain how your things are built up. So if you have this horribly scary regular expression that you kind of don't really want to touch even, or maybe look at, you can just copy paste that into that reg.ex thing, and we'll just make this train diagram thing out of it. It's much easier to read. There is a lot of online. You just search for like online regex matcher things that would do the matching things for you. And when you're actually starting to feel a little bit bold and crazy and everything, there is something called regular expression crossword or something like that. It's actually a really cool thing. It would just give you like a crossword thing with all those squares, with empty squares, where you can put words and letters and stuff. And it would give you, instead of giving you hints, it would give you regular expressions. So you actually have to fill in the words that match that. That's a lot. That's actually really good training, but it's kind of time consuming, and you end up like, okay, one more, and that's like, it's 9 o'clock in the morning. You're been sitting all night, and that happens. To a friend of mine, not to me, no. But well, yeah, friend of mine. It's always friend of mine. I don't know. I think it's the easiest way to do that is just to try and just to see how you actually can improve your and try to solve those crossword thing. The puzzle thing is really good. I think it's really fun. They have like different levels and stuff, and it's fun. Try that. Any more questions? There is one hand over there.
How about parsing multi-line patterns?
Yes. That's okay too. I didn't cover that much but you can do that as well. Basically, what you can do, the easiest way. I mean, this like something that I would come up just off the top of my head. It would be just to make sure that you actually have the character returns and everything in your regular expressions. You would have like \n and stuff like that. That's the simplest way. But there are also, again, your different patterns, your different flavors and everything. They would have like their own way of handling that. But you can do that. That's for sure. Definitely.
Another question is, why is this $sign needed in the end of the string? If it's, for example, dot asterisk, then why is the dollar needed?
That's actually to match all the way till the line break.
But would dot and asterisk, wouldn't it do it?
Otherwise, it would go. Yeah, well, that's the thing. Yeah, that's a good question actually. I think it's. I'm not sure actually about that. I don't remember exactly the reason for that right now. But I think it has something to do also with the performance and backtracking and everything. I'm not really. That's a really good question. I'll try to actually. Now I want to check that thing out. Anyone knows the answer? No, nobody. There is a hand over there. Might be a question, might be an answer.
Wait, hold on.
Okay, he's thinking. It was the scratching of the lobe. No? No, okay. There's another question. Or
have you had experience or any comments on multi-step regexing? For example, first step cleanup, second step extract something, third step extracts that shiny, complicated stuff.
Yeah, and actually, in at least my experience, that's what I usually do. I just split them in different. That's actually a very good also question because that's what I would often do is to actually split it up in different lines and do it like gradually. Because if you put all that logic in one thing, it's like one thing is you will not be able to read it in like 3 weeks because you're like, what the heck I was thinking, right? And if somebody else gives you the code, then you're also quite leaving kind of dangerously, right? So that's the good point, and it's a very good thing I think to do. At least what I do, I just do it gradually. At first I strip things, and then maybe I use one of the groups or several groups to do some other things. And I think it's maybe not the like the guru way of doing that, like all these Perl gurus and the other ones. They would be like, you can do it in one-liner, but yeah, you can do that, but you can't read that afterwards. So that's a good point, and do that. Yeah, that's I think a good idea to do that.
Come up with an example for the why the $sign is needed.
Oh, perfect.
Yeah, that's how I've used it. For example, when you need to match like files extension or something, you know that you should have like 3 letters. So you're gonna use a quantifier, for example, dot. Yep. And a letter or whatever matching 3 times. Mm-hmm. If you omit the $sign, it will match those 3, and it will also match files with extensions that have more than 3 letters.
Oh yeah.
But if you specify the $sign, it just tells the regex that that's what it ends. So it only has to have 3, and that's it, and nothing else. So that will match.
Maybe that thing, and also maybe sometimes you will actually get the character returns also as a part of that thing. I'm not sure about that. That's also again the implementation thing. But yeah, that's I think it's a good point there. I'm not with the 3 letters. You can also use the quantifiers, of course, but.
Hi.
Hi.
Actually, I have 2 questions. One leads to another. And first of all, there was a picture about 99 problems, and you use regex, and there is a 100th problem.
Yes.
So does it really? Is it really a problem for you?
Well, it's kind of in a way, when you try to introduce something and then you do it like really in a really bad way, it might get a problem because I mean we saw that, right? Lots of regular expressions that looked simple, that would do simple thing, just match a IP address or whatever. It would be looking fine, but then you actually create a problem because you're getting too many matches. So that might be the problem, and that's usually it's also the reason for that is sometimes that you haven't thought about all those things and well, after this presentation, hopefully there will be actually still 99 problems, probably, hopefully less, even 98 maybe, and a half.
And so the second question,
yes.
In the solution to how to find an IP address, there was regular expressions, and you actually repeated yourself so 4 times. You said to use quantifiers, but I don't know the way how to use them because you use them and you match the dot in the end.
Yeah, I know. That's the thing. So you actually have to do something smart there. You have to say that maybe a dot or that's another thing. That's one of the reasons why I actually did not use the quantifier is actually to avoid that because you actually have to put the logic for the dots as well. You have to say that it has to be there, but not there and not on the end. It's not going to be last character. You can use like look aheads, look behinds, and all those kind of things. That's one of the reasons that I wanted to keep it simple and just repeat myself instead. There is a comment over there, and probably we're running out of time. I don't know. How are we doing on time?
The last question.
Last question. Perfect. It's probably a comment, I think, but. Yes.
Just follow up on the previous one. Wasn't there such a thing as sub-patterns? Like you define your pattern and reuse it as many times as you want?
Yeah, you can do that.
And put dots in the middle.
Yeah, you can do that as a back references. Yes, you can actually fix that with back references. Very good point. That's also like the one I used with the emails, like \1, \2, and so on. So you can define that and you can refer back to that and say that, I can repeat that. So that's actually a very good point. Yes, thank you. So this is me, and well, the voting thing. Just remember to vote. Totally random number, or color, I mean. Thank you.